Hello. I'm going to start off with saying sorry about all the shadows and all the weird places. I don't know why it's not really been an issue before, but it is now, but that's okay. So, you're going to really appreciate the derivative of the ln of x is 1 over x, because the derivative of logarithms with different bases is not going to be quite so easy, but we can still do them, so let's do it. Here are a couple of the logarithm properties that we're going to use today. I just wanted to stick them right here as a reminder. Here we want to find dy dx, and so what we're going to do, before we do any derivatives, we're going to do the natural log of both sides. And the reason we do that is because here you use that property where you can move the exponent down to the coefficient. Here we're going to do the derivative with respect to x. And so on the left side, it's not so bad. You have ln of y, that is going to be 1 over y. Just remember to do dy dx because of the chain rule. We are doing the derivative with respect to x, and it is not x. This next part's a little tricky, so I went back to the other picture. We're going to do the derivative of x ln of 25. So this is where I like to use the example. If it was the derivative of 10x, we would get 10. And so that's what you have to think of it, is it's some coefficient times x, so its derivative is that coefficient. So the derivative of x ln 25 is ln 25. So you want dy dx by itself, and you're going to need to multiply both sides by y, and then you substitute y with what you had in the original problem. And that's your answer. So in this example, you do the same thing. You're going to do the natural log of both sides, and then you're going to move the exponent out front into the coefficient. And then when you do the derivative of the left side, that's the tricky part with the chain rule, you're going to do 1 over y and then times dy dx. And then on that right side, just remember it's x times a constant, so the derivative of that is the constant. You want to get dy dx by itself, so you multiply both sides by y, and then you substitute. So to start off with, this one's a completely different problem. You're going to do the derivative of this logarithm, but it's not a natural logarithm, so it is more work. And if you don't remember the logarithm properties, go back to the beginning of this video, and you'll see that I just changed this. To start off with, it was a logarithmic equation, and I changed it to the exponential form. So now it looks a lot like the problem at the beginning. We're going to do the natural log of both sides. And the reason we do that is so we can move the exponent out front. And then on that left side, when you try to do the derivative, it's just y times some constant. And that is 1 dy dx times the natural log of 7. Remember to do the chain rule. And then on the right side, we're going to do the derivative of ln of x, which is just 1 over x. Then we want to get dy dx by itself, so you just divide by ln of 7, and so it looks funny, but that's what you get. Here's a similar example. We have the logarithmic equation. We're going to change it to its exponential form, and then when we have that, we're going to use it, the natural log of both sides, and then we can move the exponent out front. So we're going to do the derivative with respect to x on both sides, and on the left side again, you have y, so you're going to end up with dy dx, but it's just y times a constant, so it's going to be 1 times dy dx times that constant. And then on that right side, it's just 1 over x. And then you want to get dy dx by itself, so you divide. And then you're done.